In this section, we're going to be solving quadratic equations by graphing. When we're working with solving equations by graphing, we're looking at the zeros of a parabola. So just some things to point out here. Quadratic equations, remember it's an equation that's written in standard form, ax squared plus bx plus c equals 0. And one way to solve quadratic equations in standard form is to graph the related function. So you graph the function. You would then find the x values where y equals 0. In other words, what you're doing is you're finding your zeros of a related function and recalling that a quadratic function may have 2, 1, or no zeros at all. And that's what we're going to be looking at here in this section. Here are the various steps. Here are 3 steps you need to think about when solving quadratic equations by graphing. First, you're going to write the related function in the form of ax squared plus bx plus c. You're then going to graph that related function, and then you're going to find the zeros of that related function. And by finding the zeros, you're going to determine if you have one solution, 2 solutions, or no solutions at all, based on looking at your zeros. So let's get into some examples of this. We're going to solve the equation by graphing the related function. So here we have this function, x squared minus 8x minus 16 equals 2x squared. So we need to think about, is this in that standard form? Ax squared plus bx plus c. No, it's not. So what we need to do is we need to write a related function to that. So to write a related function, that's going to be x squared plus 8x plus 16. How did I get that? Well, what I did is I moved everything from the left over to the right. So I subtracted x squared, I added 8x to both sides, and I added 16. So when you add your x, when you subtract x squared from 2x, you get your x squared. When you add 8x to both sides, that's how I get my plus 8x. When I add 16 to both sides, that's how I get my plus 16. So I moved everything from the left here to the right to get this in the standard form, my related function. My second step is to graph this. So first we need to find the axis of symmetry. Remember, you used that equation, negative b over 2 times a, to help find your axis of symmetry, or your x. You then find the vertex, and to find the vertex you plug in that negative 4 into the equation to find your y. And my vertex here is negative 4, 0. We then find the y-intercept, so my c value. What is my c value? My c value is 16. And then we can find 2 other points that would fall on the graph, and we create our graph. So this is what our graph looks like. Here we have my axis of symmetry is at negative 4. My vertex is negative 4, 0. And then it's going to cross the y-axis at 16. 16 is pretty high up there. So that's how we graph this, though, based on plotting other points. And so looking at this parabola right here, does this parabola cross my x-axis anywhere? It does, at the value negative 4. So what we can say here is this graph does have one solution, because your parabola crosses the x-axis at one point, or one place on the x-axis, and that's at the value negative 4. So in order to determine how many solutions it has, you need to go through all of these steps, 1, 2, and then determine where your parabola crosses the x-axis. If there's any zeros, here we have 1 0 at the value negative 4. Example number 2, again we're going to solve an equation by graphing the related function. Here we have 6x plus 10 equals negative x squared. I'm going to actually add my x squared to both sides. So what I have now is x squared. Well, we'll put this here in step 1. What you have now is going to be x squared plus 6x plus 10. So that's our related function, so y equals that. Second step, we need to now graph. So we first find our axis of symmetry, negative b, so negative 6 over 2 times 1 gives me negative 3. To find the vertex, you substitute 3 into the equation to find your y value. So my vertex here is negative 3 comma 1. The y-intercept is your c value. Remember your c, which is 10. And now we can graph. We can set up our graph and then find other points that would fall on the graph. So let's first put our vertex, which is negative 3 comma 1. Here it is, the blue dot. That also is representing my axis of symmetry. I can plot a few other points. Notice I've plotted a few other points on the graph. Now looking at this particular parabola, does it fall on the x-axis anywhere? Notice my vertex is negative 3 comma 1, but it does not fall directly on the x-axis itself. So since this parabola does not fall on the x-axis, there's no zeros, there is no real solution here. And as I mentioned earlier, it's because the parabola does not cross the x-axis at any point. So here we would have no solution for this graph. For example 3, we are going to be getting into something similar to what we've been working on, but what we have here is negative x squared plus 4 equals 0. And notice we do have a negative sign in front of my x squared. This is already set up in the standard form, so we just think of this as negative x squared plus 4. With that negative in front of the x squared, what we need to think about is our parabola is going to open downwards instead of opening upwards. So we're going to graph this, and they're actually going to use a graphing calculator, and we haven't been working with a graphing calculator. So we need to go through our steps of finding the axis of symmetry, finding our vertex, finding our y-intercept, and then graphing it. As you can see though on this graphing calculator example, we do have my vertex, we have the graph crossing at 2 places on the x-axis, so we do have some 0 values. So let's look here to see how this works out. So for step 3, we find our zeros, and the zeros for this is going to be 2 comma 0 and negative 2 comma 0. And there are solutions since this does cross on the x-axis. So we would say the function does have 2 solutions. The parabola crosses the x-axis at 2 points, which is at the value negative 2 and 2. So after you've graphed this and found that there are zeros, we have 2 solutions at the values negative 2 and 2.